Okay, this is Mrs. McIntosh, and I'm going to go through the numbers on, or through the notes on comparing and ordering rational and irrational or real numbers. Let me make it a little bit bigger so that you can see. And we're going to talk about how we would do this. Yesterday we talked about approximating irrational numbers, meaning finding a value to the nearest tenth or hundredth or thousandth. And that's basically what you do when you're comparing real numbers. You find their decimal value to a certain place, and then you figure out what's bigger and what's smaller, or put them about where they go on the number line. Here I have a number line with a bunch of real numbers on it, and we're going to do another one down here. But first, let's talk about this. Fill each box with the correct symbol, greater than, less than, or equal to. So is the square root of 3 greater than, less than, or equal to 1? Well, hopefully you have your Desmos calculator open. We're going to do the square root of 3. And look at that. It's about 1.7. So what goes in this box? Let's put a text box right here, actually, and I'm going to put 1.7. I'm going to make that smaller, though, because that's like way too ginormous. This 1.3 is about 1.7. Greater than, less than, or equal to 1? Obviously, it's greater than. So, oh, shoot. We don't have the thing that shows me yeah. Actually, I'll type it from here. That would be greater than. So, square root of 3 is greater than 1. B, 1.5 and the square root of 2. So again, put the square root of 2 in the calculator. We got about 1.4. So I'm going to put that right there, about 1.4. And how does that compare to 1.5? Well, 1.5 is greater than 1.4. What about 3 compared to the square root of 12? So let's go square root 12. Well, I don't want that all together. Square root 12. And that's about 3.5. I'm going to put that right here. 3.5. So 3 compared to 3.5, I believe that would be less than. Okay, 20 over 9. Ooh, that one I've got to put as a decimal too. So I'm going to do 20 divided by 9. That's 2.2 repeated. So I'm going to type that down here. 2.22222 gives me the idea. That's 20 over 9. And the square root of 6. Again, the calculator. This is pretty easy to do. Looks like about 2.4. So I'm going to compare 2.222 to 2.4. What goes there? I'm going with less than. Okay, negative square root 7. This is where it gets a little tricky. Let's think about this for a second. Let's do the square root of 7. Just kidding. Square root 7, which is about 2.6. So I'm going to put negative 2.6. And then here I have negative 2.6. Does that make those equal? Does the negative square root of 7 actually equal negative 2.6? No, it's negative 2.64575. I'm going to type some more of that. 2.64575, and it goes on from there. That's important to know, because is that bigger or smaller than 2.6? Well, first we have to think about negatives. If I have a number line, here's a number line for me. And I'm going to put some numbers here. Here's 0. And here's I don't know, 5. And here's negative 5. If I have negative 1 compared to negative 5, which is greater? Negative 1, which would be about here, or negative 5, which would be about here? Negative 1 is greater because it's farther to the right. Negative 5 is more negative than negative 1. That makes it less. So which one of these numbers is more negative? That would be this one, because this one would have zeros after it. So this one is more negative, which makes it less. A number that is more negative is less than a number that is less negative. Hopefully that makes sense to you. We have 9.5 compared to pi squared. So luckily I've got a pi key on my calculator. I'm going to go pi. And then look at this over here, a squared. I have a key that will square that. So 9.8696. So I'm going to call that 9.87. Here I go. 9.87. Is that bigger or smaller than 9.5? It's bigger, so I'm going to put a less than sign here because 9.5 is less than pi squared. Hopefully you understood that all I need to do, and I'm going to write some notes, find the decimal expansion in the calculator and compare. That's how you do this. Find the decimal expansion in the calculator and compare. I'm also going to type, be careful, maybe. Wow, struggling. Be careful, shift, exclamation point. Numbers that are more negative have less value. So that's very important to remember. In fact, I might change that whole thing to like red. Be careful. Numbers that are more negative have less value. We need to remember that. Okay, so coming down here, we're planning an art exhibit. One of the artists is a former math teacher. Each artist sent you the heights of their paintings. You want to display the paintings from shortest to tallest. Show how you displayed the paintings. Okay, I got a 1.6 feet. Okay, so that's, I'm going to use a text box again. I'm going to go 1.6. That's the decimal value of that. Then I'm going to do a decimal value for the square root of 7. Again, calculator, and round it to the nearest tenth. That would be about 2.6. I'm going to put that right there, right under the square root of 7, so I know what that is. Then this one's the square root of 5. I'm putting that in the calculator. That's about 2.2. Then I have 2 feet, so that's just 2. Then I have 2.8. I'm going to type that here. The reason I'm typing these all, even though I don't have to do anything, I'll show you in just a second, because then I need the square root of 2 feet. So the square root of 2 is about 1.4. Here we go. Now watch. I can pick up this text box and put it in order. Which one's the shortest? What's my lowest number here? I got a 1.6 and a 1.4. That would be 1.4. I'm going to pick up that 1.4 and put it right there. Which is actually, you know what? I'm not going to do that. Because I want to put what they gave me. They didn't give me 1.4. They gave me the square root of 2. So I am going to put the square root of 2 in there. And that means I got to make my screen a little smaller so that I can see my function here. It's all right. I'll change it to bigger again in a second. Square root 2. When they ask us to put numbers in order from least to greatest or greatest to least, We want to put the numbers they gave us, not our decimal approximations, okay? So that was that one, and I'm going to put it here to go with it. So I know I already used that one. And that's a good idea. I can put them up here. What's my next biggest? That would be the 1.6, which was what they gave me. So I'm going to put 1.6 in there. My next one would be, let's see, I got 2.6, 2.2, just 2, and 2.8. Looks like 2 would be my next one. And that's what they gave me, was 2 feet. So I'm just going to put a 2 in there. Then I have, my next would be 2.2. But that's not what they gave me. What did they give me? The square root of 5. So I'm going to put a text box in here and do the square root of 5 right there. Then my next would be this 2.6, which is an approximation of the square root of 7. And I know I'm going kind of fast, but if you get behind, just watch and you can catch up your notes later when you're at home. And then I have 2.8, and that's what they gave me, was 2.8. Remember, you can watch this at home as well. It's right in your lesson. You just have to click on it. Okay, write these numbers in order from least to greatest. Here I have pi, the square root of 11, 3.4, and 3.1. In order to do this, I am going to draw a number line and put these numbers on a number line. This is a good way to put numbers in order from least to greatest. Okay? So I'm drawing a number line. I kind of know about where these numbers are. So I'm going to do my approximation here. Pi is about 3.14. We all know that. Square root of 11 is about 3.32. And the reason I'm doing more than one place here is because these are all 3 point something. 3.32. And then I have 3.4 and 3.1. Okay? So I need a 3 down at this end. And I'm just going to put the numbers right on the number line here. And a 4 down at this end. So about the middle would be about what? What's halfway between 3 and 4? Correct, 3.5. Okay, now I'm going to go to my drawing and do a dot. Maybe I'll do red. So, pi, 3.14, that's about 3.1. If this is 3.5, I got about 1, 2, 3, 4 in here. So I'm going to put it right about there. And I'm going to label that. What? What did they give me to put on the number line right there? Because it wasn't 3.14. They gave me pi. So that's what I label my point. Pi. Then I got 3.32, or about 3.3. Ooh. Okay, if this is about 3.1, I'm going to go back to my drawing here. 3.1, 3.2, 3.3 right there. But what was it they gave me? Because it wasn't 3.3, it was the square root of 11. So that's what I'm going to label that. We always want to label it with the number they gave us, not our decimal approximation if they're different. So square root of 11 is that point right there. Then I have 3.4. I'm going to go back to drawing. 3.4 is about right here. And I'm going to label that 3.4. And then 3.1. Ooh, here's the question. Is 3.1 bigger or smaller than pi? Well, pi is 3.14, and 3.1 is 3.10, so it is smaller. So I'm going to put it like right next to there, but on the left. And I'm going to label that 3.1. Move it so we can read it, and I'll move the pi over just a little bit. In fact, I'll put pi down here. There we go. Now we can see. Now, in order to put the numbers in order from least to greatest, all I have to do is read them from left to right. Least to greatest. So, text box, 3.1. Then I have pi. Then I have the square root of 11. So, comma, space, square root of 11. I have to arrow out of that and then put a comma so it doesn't keep doing the square root. Then I had 3.4. And there's my list in order from least to greatest. I had 1, 2, 3, 4 numbers there. I have 1, 2, 3, 4 numbers on my list. They're in the right order, left to right, because I put them on a number line. I know for sure that's how they go. So using the number line is a really good idea when putting numbers in order from least to greatest or greatest to least. Here they want me to do greatest to least. I'm going to do my decimal approximations again. I've got the negative square root of 17. I'm just going to put square root 17 in here, and then I'll make it negative when I transfer it over. So that's about 4.1. So negative 4.1. There. This one is 5/3. 5 divided by 3. 5 divided by 3. 1.6 repeated. So 1.666 ... is going to give me the idea. Or I could have just done 1.6 and draw a line over it, but I'm trying to hurry. Okay, negative 17 over 4. I'm going to type that down here. Negative 17 over 4. I'm going to do 17. Oops. 17 divided by 4 gives me 4.25. So I'm going to type that there. Square root of 9, I already know that without the calculator. If you don't, you can put it in the calculator, but it's 3. Negative 1.7 is negative 1.7. Negative 1.7. And the square root of 3, go into my calculator again, about 1.7. So 1.7. All right, now remember, numbers that are more negative are least. So my negative number that's the most negative is negative square root 17. And you should type negative square root 17 here. I'm trying to be quick, but this is getting much longer than I wanted it to be. Oh, I got to do negative first. Negative. Then I want a square root 17. And I'm going to put that in my first box. Okay, then what's my next? Well, I have one more negative, negative 1.7. And that was the same. I'm just going to drop that down in that box rather than retype it. Okay, now I'm up to positives. Which one's my lowest one? I think that would be my 1.6 repeated, which was 5/3. So here I'm going to type my 5/3. I'm going to do this A over B. 5 down 3. There's 5/3. Then what's next? I got 1.73 and 4.25. I think the 1.7, which was the square root of 3. So I'm going to type square root 3 here. Square root 3. Guys, they said greatest to least. Oh, I'm glad I caught that now. Here I go. Changing them around. 5/3 needs to go here. Square root of 3 needs to go here. This negative 4.1 was here. 1.6 repeated. Come on. Was not 1.7. That was 5/3. Negative 1.7. I don't know where that went. Okay. Whew. So least over here, greatest over here. What's my next biggest one? 3. So I'm going to put square root of 9 here. There's my 3. And I'm going to do, this needed to be negative. That's the confusion. Negative 1.7. Oh no, negative, oh, 1 point, whoop. Yeah, I'm all messed up. 1.7 was about the square root of 3. That's where that goes. We just dropped this decimal 1 down in here. That's right. Okay, 3, which was the square root of 9. Whew. Glad I caught that before I submitted my test or something. It's always a good idea to double and triple check your directions, right? Square root of 9, and then my lowest is negative 17 over 4, which should say negative 4.25. I'm going to put a negative there. Negative 4.25, which, if I pull up my thing here, I can go A over B. Oh, but I need to do the negative first. Negative, and then 17 over 4. There we go. Now, wait a minute. That was... That's really the least, isn't it? Negative 4.25. I'm going to move that down. You see, even teachers make mistakes, and this is kind of how it goes. This is why when we're taking an assessment, we use a pencil that has an eraser, or if we're on the computer, we don't submit until we've checked the question again and made sure that our answer actually answered the question. So the least is the most negative. The greatest is the one that's the least negative. So there we go. Good job. I think we're ready to go. Values from least to greatest. It's that greatest to least that gets me every time because I'm used to doing least to greatest. I want you to do least to greatest on this. Go through, write the decimal approximation, and then move them around. Put them in order, guys. Thanks for your attention. Hopefully this helps you with comparing and ordering rational and irrational numbers.